They say nothing escapes a black hole. Not light, not matter, not even time as we know it. But that just scratches the surface of what's really going on inside. The truth? It's far stranger, far more disturbing, and far more fascinating than you've ever been told. Because when you cross that invisible boundary of the event horizon, you're not just falling into darkness. You're re-entering a region where the laws of physics as we understand them start to fall apart. And what lies at the center is something no one can fully explain yet. Let's rewind for a second. Imagine a star, not a small one like our sun, but something dozens of times more massive. It burns violently for millions of years until it runs out of fuel. Then, it collapses. And if it's massive enough, it doesn't just shrink, it implodes, crushing itself into an infinitely small point. This is what we call a singularity. Now, infinitely small doesn't even make sense in normal terms. It's not just small, it's a point where all the mass is concentrated into zero volume. That means infinite density. That means gravity so strong that space and time themselves bend and fold into something alien. Here's the part that will break your brain. To an outside observer, it looks like anything falling into a black hole just freezes at the edge. It slows down, red shifts, fades away. But the object falling in, it doesn't feel that. It plunges past the event horizon in a fraction of a second, and what it sees inside is completely unobservable from the outside universe. Now, according to Einstein's general relativity, once you're inside, all paths forward lead to the singularity. Time and space switch roles. You're not falling toward the center, you're being pulled through time toward a moment in your future that is the singularity itself. You cannot avoid it, just like you can't avoid tomorrow, except tomorrow is a place you'll be crushed into no. But here's where it gets controversial. Quantum mechanics, our other great theory of physics, says that information can't be destroyed, ever, but when you toss something into a black hole matter energy, even light, it seems to disappear forever. So where does the information go? This is called the black hole information paradox, and it's torn physics apart for decades. Stephen Hawking once said, black holes evaporate slowly through a process called Hawking radiation. That's mind-blowing in itself. A black hole could eventually vanish completely. But if that's true, and the information never comes back, we've got a problem. A big one, because if information can be destroyed, then quantum mechanics is broken. And if quantum mechanics is broken, then everything we understand about atoms, particles, and the universe itself might be incomplete. Some physicists have proposed solutions. Maybe the information leaks out through subtle changes in the Hawking radiation. Maybe it's stored at the event horizon on a 2D surface, a theory known as the holographic principle. In that version, our 3D universe is just a projection from a 2D reality, like some cosmic illusion. Others believe that black holes might not have singularities at all, but instead could lead to other regions of space. Sounds like sci-fi? But the math doesn't rule it out. It whispers that maybe, just maybe, a black hole is a one-way tunnel somewhere, and we haven't even talked about Planck-scale physics, the realm where gravity and quantum mechanics must merge. Inside the singularity, we'd need a theory of quantum gravity to truly understand what's happening. Right now, we don't have one, which means our best models break down exactly when we need them the most. So, what's really inside a black hole? Possibly an endpoint of matter? Possibly a beginning of something else. A place where cause and effect no longer make sense, where time doesn't tick forward like a clock, where every rule we've built our science on, it's not just a graveyard for dead stars. It might be the deepest secret the universe is hiding. The truth is, no one knows for sure. And that's not because we're not smart enough. It's because the laws that define our universe stop working there. Which means, to understand what's really inside a black hole, we don't just need better technology. We need a new way of thinking, a new physics, one that hasn't been written yet. And maybe when we crack that, we won't just know what's inside a black hole. We'll finally understand what reality itself is made of.